Hey guys, welcome to another lesson. So today we start a new series of videos on the inverse trig topic in the extension 1 syllabus. So what I've done is I've collected a few sort of themes in the inverse trig topic. So the first one I'm going to do for you is sketching a domain arrange. And over the next few lessons, I'm going to explore things like calculus, explore things like some harder questions later on as well. So, yeah, I think it's a pretty nice topic to do. Some students find it quite hard at times. So, I thought I'd bring it to you guys. Before I go on, as always, if you like the video, please subscribe to the channel, like the video, and tell all your friends. So I'm going to start this video by doing a little bit of theory on domain arrange, right? And the sketching element of it. So sketching inverse trig is actually really simple. Once you know the domain arrange, sketching it is really straightforward. It's almost like, and you see later, all I'm going to do is do a box and then do a curve through it. All right, I'll show you what I mean. So, guys, sketching inverse trig plus domain arrange, right? So I'm not going to really get into the why things are. I'm just going to summarize for you sine inverse, cos inverse, and tan inverse, right? Their graphs, I'll draw their graphs and also summarize their domain arrange, right? So when it comes to sine inverse, right? So we know that all inverse functions are one-to-one, right? All inverse functions are one-to-one functions where we basically restricted the original sine graph, right? Before we inversed, we restricted the domain. And so when we inversed it, it was one-on-one. So we inversed it, it still remains one-on-one, right? So for those that remember, the sine inverse graph, basically it's a sine curve on the side, right? Right, that sort of looks like that, yeah, where this is 1, this is -1, yeah, and the two endpoints are pi on 2 and negative pi on 2, right? Yeah, that is essentially, right, your sine inverse. Now, in terms of domain arrange then, just by looking at that, it's quite obvious that the domain is between -1 and 1, and the range is between negative pi on 2 and pi on 2, right? Really straightforward. Yeah, capture that down, right? So that's a summary of sine inverse. Let's do cos and then do tan, and then I'll just hit up some past paper questions that deal with this concept of sketching a domain arrange, right? So cos inverse, exactly the same, really, right? But for those that know the cos graph normally, right, it starts with 1 and ends with -1, right? So we had to sort of restrict the domain in a different way, right? Where for those that know the inverse graph, then it's basically largely positive. Two things, it's all positive, it's sort of shifted up, and also it's reversed around, right? So it sort of looks like that, but this is 1, that's -1, and the highest point there is pi, which makes that obviously pi on 2, and that's the origin there, that's x, and that's y, right? So in terms of domain arrange, domain is exactly the same as a sine, so bound between -1 and 1. But for the range, it's now bound between 0 and pi. Yeah. So all of this now, your teacher at school, if you haven't already done so, should explain to you the reason why the sine curve needs to be restricted. It's mainly because inverse functions only occur when it's one-to-one, right? We can't have many-to-one or one-to-many for an inverse function to happen, right? Now, lastly, tan inverse, which is always the weirder one, right? Looks like this. So we basically have a tan graph, but we basically have a tan graph, and then we restrict the domain to negative pi on 2 and pi on 2, which takes one of those, two of those asymptotes, and then we put it onto the side. So we basically turn it into a sideways trig graph. It looks a little bit like that, all right? Where that's pi on 2, that's negative pi on 2, that's the origin, right? That's x, and that's y. Which means when it comes to domain arrange, domain is all real x, Yeah, and the range, now, it's asymptotes, right? So y is capped between, but not equal to pi on 2, pi on 2. Now, and thereafter, guys, the past paper questions I'm going to dive into now, like, I think I've seen, God knows how many past papers I've seen, but I'd say 97, 98% of all questions are sine inverse and cos inverse related, right? So for the sake of that sort of proportion, I'm just going to focus all my attention on the two graphs and just manipulating the two and touching on examples on that, right? So shall we hit up some past papers? So hopefully you guys know all this, right? This is just a recap of the formula you know, right? Now, once you know this, let's dive right in, right? So where's this one from? James Roos, right? So James, this question here is a classic breakdown. They give you an inverse graph that is manipulated, right? Transformed. And then they go find domain and range and then sketch the graph. Now, the technique that I always tell my students is firstly find domain and range and then use a box method to sketch. I'll show you what I mean. So when you find domain and range, there is two things I want you to do separately. Domain and range, they're actually separate, right? Two different ways. So if I write down the function that they want me to find domain and range of, right? Cos inverse. For the domain, right? Always take the function inside the inverse, right? And put that between the two x values for cos inverse's domain, which we know to be -1 and 1. Once you do that, the simplicity of it is then you just make x a subject, right? You go cell x -1, so +1 on both sides. It becomes 0 and 2, right? That's the domain, tick, right? Then for range, we basically take this guy, right? And go for range. Now do me a favor when you do this, right? Take that guy and put him between, I know that cos inverse is always between, now I'll give a little space, right? And I'll explain why I need a bit of space. Right? Between 0 and between 0 and pi. Yeah. Now, this is the trick, right? I say this to my students. What I want to do to get the full y value, right? Because that's y, right? It's missing the half in front. So what I'm going to do is I'm going to introduce half. I'm going to multiply that by half, times that by half, times everything by half, right? Because the moment you times it by half, guys, this thing here becomes y, right? Because that looks like my original y, and then 0 times half is 0. Pi times that's pi on 2. Guys, I now have my range, right? By making this look exactly the same as this, it becomes y, right? And that's my range. So in this question, just to recap, and this is the method that I'll do for all the questions we see domain and range and sketching, right? Even if it doesn't ask you to define domain and range and they ask you to sketch, you use this method. So to do the domain, you basically take the function inside the inverse and put it between -1 and 1, right? For cos inverse, same with sine inverse. For the range, you take this guy here, the cos inverse part, and put it between 0 and pi, because that's the cos inverse range. And then you try to manipulate it, put the half there to make it look like y. Once you do that, guys, you have the domain and range. That's 2 marks. Now, part 2 is super easy. Yeah, because I know the cos inverse graph initially looks like this, right? It looks like this. Yeah, as a shape. The reason why I'm telling you, because when we sketch this guy on a bigger number plane, right? Yeah, this is X, this is Y. Guys, I know my range is between 0 and 2, right? That's what my domain is between 0 and 2, and my range is between 0 and pi on 2 up here. Now, I always ask my students, and I'll actually draw it for you, right? Because I have the ability to, draw a rectangle, right? Yeah, no fill. Now I'll draw this a little bit brighter. I always use a rectangle as a demonstration of what I want. Now, you don't need to draw the rectangle, right? It's just for you to visualize, because my inverse graph is basically within that rectangle. Now, once you know, right, once you know how wide this rectangle is, and once you know how tall this rectangle is based on domain and range, then it just comes back to a simple case of putting the curve in. I know this is cos inverse, so it starts top left and ends bottom right, and it just goes, boom, done. That's the answer. How easy is that? Domain, range, top left, bottom right, boom, done. And if you're really cool about it, you tell your teacher that because it's symmetrical, in the middle there, that's 1, there, pi on 4. And that's it. All right, guys. That's as simple as it needs to be, right? So the box method, you don't need the blue box, right? Just delete it after, but that's how you do it. All right, let's do another one. Yeah, let's do another question. So, Newington. Now, what we've got here. So, once again, they give you a function. Domain, range, boom, same thing, but split. Wow, that's a lot of marks for these, right? Yeah, much more than before. So if I had function, just let that be y now, 3 sine inverse of 2x minus 1, right? Same deal, guys, same deal. This guy here, right? I'm going to put it for domain between 1 and -1. Put the plus 1 to both sides, that's 0, 2x, 2, divide by 2, 1, 0. Yeah, pretty straightforward, guys. That's 2 marks. Wow. Okay. You know what? Let's do the next one. That's decent. Now, next one, remember I said to you, put the inverse part only, right? Put the inverse part only for the range. 3x minus 1 between the range of sine inverse, right? Which is negative pi on 2 and pi on 2, right? When it was cos inverse, it was 0 and pi, right? Sine inverse slightly different. And then we just need to manipulate, get the 3 in there, right? The 3 there, so times this by 3, times this by 3. Once you do that, guys, this becomes a range, right? This guy here, that's y. And then negative 3 pi on 2, 3 pi on 2. That's it. That's range. And the one before was domain. Guys, 4 marks so far. That's very very generous, right? I don't think it's usually that generous, right? And then for part 3, we sketch, right? Part 3, we sketch, right? Now, shape-wise, I know that for sine inverse, it sort of looks like that, right? So when I sketch this, right? Let's see. You know, I'll go back a slide to get my box, right? Keep it up my sleeve. All right. Now I know the width is going to be from 0 to 1. Not to scale. Oh, maybe I'll make it a little bit to scale. I think like compared to this. Negative 3 pi on 2, pi on 2. So it'll be 3 pi on 2 here, and negative 3 pi on 2 here. And guys, that's so I got my height and my width. So let's try and make this happen, right? So obviously my rectangle is 2 straight. So what there? Right, broadly as a guide, guys. Broadly as a guide. I'll delete my rectangle at the end of it. But once you get that, now it's as simple as I want the shape to look like so top right, bottom left, and I want it to slide down. Now it actually hits the middle right above there. So I'm like, that's my answer, guys. Delete your box if you may. Right, nothing hard about that, right? That's why that's X. So if anybody says you sketching trig graphs and domain ranges hard, they're kidding themselves, right? It's just 2 parts that look like that. 6 marks there. It was 3 marks in the one. I think 3 marks is actually more realistic, right? Another one. What's this? Penrith. Okay, cool. Now this one here has just a little bit of a catch that I want to demonstrate, but the same 2 questions can you see, right? Just a little bit of a catch, right? And that catch is that negative in front. So just be careful with that. So part 1. So once again, domain range. So y equals to negative 4 sine inverse 2x on 3. So step 1, as always, domain. So I'm going to put that for the domain 2x on 3 between -1 and 1, right? Times 3 to both sides. And then divide by 2, right? That's my domain. Yeah, simple. Simple, simple, simple. Yeah. Now, range, right? So off to here, I got sine inverse on 2x on 3. Now this is sine again, right? So less than or equal to 0. Sorry, too much space, right? 0 and less than or equal to. Sorry, not 0. I'm thinking about cos there. My apologies. Negative pi on 2, pi on 2, right? All right, I need -4 then. Now, when I multiply this by -4, right? Just be careful, right? When I multiply everything by -4, the sign flips, yeah? Sign flips, so it becomes like, that's y now. Becomes that. -4 times that, what's that? -2 pi. And that becomes 2 pi. And then you just reverse the order of this, right? So minus 2 pi. And that is my range. Simple, right? Simple, simple, simple. Once you do that, guys, now, the next part is where there's a little bit of a catch, right? So part 2, I know that sine inverse sort of looks like this. Yeah, the only catch for this, because I'm doing negative, what does a negative in front do? How does it transform it? It basically rotates, right? Or flips or reflects, right, about the x-axis. So actually this guy now becomes, with a negative, it just becomes that. It just changes shape, right? Changes the slippery dip. Instead of going from top right down to bottom left, it goes from top left down to bottom right. Yeah? So when I do this thing, exactly the same. That is like, that's the hardest thing about this. Right? It's not hard actually at all. So what's my box look like? It goes from -3 on 2. Oh, sorry, it's not 3 on 2, is it? Oh, it is 3 on 2. Yeah. 3 on 2. 3 on 2. Right? And then it's like 2 pi, which obviously not to scale because 2 pi is actually very tall. And -2 pi, right? And then, do I still have my box? Yes. Still have my box. No. So guys, that's my box. Now, once you get your box in, instead of going from top right down bottom left, because of the negative, it just goes the other way, right? So I basically start here and I end here. And I know it's all symmetrical, so I'm middle here. It sort of goes like that, something like that. And then delete your box. Yeah? That's my answer, right? Guys, not hard, right? Convince yourself, please, right? Not hard. Got one more, and then I'm done, right? One more. Yeah, Kalara. Now, determine domain range and sketch out all 3 questions. All these questions are the same. It's just 3 marks. I think that's more realistic. That Newington one was a bit weird, right? So in this one here, so step 1, put the domain, for the domain, put 1 minus 3x between -1 and 1. Yeah, this line inverse again, right? So then minus the 1 over, so -1, so that becomes -2, and it becomes 0. Now divide by -3, so then that becomes 2 on 3. Sign flips, 0, right? Reverse that, please. Yep. Reverse that, and you get 0 less than or equal to x less than or equal to 2/3. Boom, right? Nothing too hard, right? Yeah. Range. So once again, put everything that has a sine inverse, right? Right. Now this sine inverse, right? So I'll put the sine inverse 1 minus 3x here, right? Put there, put between 0 and 1/3. Oh, so what am I doing? I'm thinking about cos inverse all the time. And this is -pi on 2, and this is pi on 2, right? All right, guys, I need to manipulate, see that half there. I need to multiply it in front, which means times this by a half, times this by a half. Quick check. Perfect. So once I do that, I know that this guy here is y, and then negative pi on 2. Oh, sorry, pi on 4 now, right? Because I'm divided by 2. Yeah, pi on 4 and pi on 4. Easy, you know, easy. Once you pop that in, easy, easy, easy. Guys, now, there is a catch though, right? Just like before, we know that if it's sine inverse, it should have this shape. But can you see the significance of a minus in front of x, in front of the x value there, right? Inside the function. Now, we know from a transformation point of view, right? When I put a negative inside the function, it rotates, or sorry, it reflects the graph about the y-axis. So once again, right? If I had a negative in front, like the last question, it rotates. If I have a negative inside, it rotates. It basically just flips it this way. That's the only thing I need to think about. So when I sketch this graph, right? Now, do I have my box? Yes, I'm going to park my box over here for a sec. Right, zoom in. So my width on my box goes from 0 to 2 on 3. And my height is pi on 4. And negative pi on 4, not to scale, right? So overlay my box there. Yeah, and then I just need to slide now. Now, instead of going like my normal sine inverse, going from top right, I start with top left and slide downwards, right? So let's do that. So from here, I'm gonna go. Oh, that's really, sorry. Try it again. Yeah. So with the digital pen, that's probably as good as it's gonna get. Now, that's it, right? Pretty simple, right? You go Y, X, and you have it. So, guys, when it comes to inverse trig and domain and range and sketching, the sketching part's actually the easiest part. Domain and range, now you have a technique, right? Domain, take the function inside the inverse, set it between -1 and 1 if it's sine and cos inverse, right? For the range, take the bit that has sine inverse or cos inverse, and then manipulate everything else to make it look like y. Once you get that, use the domain to determine your width of the box, the range to determine the height, and then slide. If there's negatives in front of x or in front of the function, flip the function, right? Guys, hopefully that was okay. Look forward to the next lesson. If you like that, once again, remind you, so subscribe to the channel, like the video, and tell your friends. Thank you very much.